Hello everyone. So today in this playlist, we're going to see the question to sum, that is from two-pointer technique basically. And what is happening is we've been given an array of integers and we have to return two such indices on which the array elements, when we sum up those array elements, the answer that we get is equivalent to the target that we have been given. So if I see the array space, we have been given the array space as 1, 2, 3, 4. Right? And the target has been given as 3. So the thing is, let's assume we have been given this 1, 2, 3, 4. And the target has been given to us as maybe, let's say, 10. So we have to get two elements that sum up to this target. And then we have to return their indices. And it is going to be 1 based. Because this is what they have mentioned to us, that we have to return the indices 1 indexed. Okay. So the first and the most brute approach that comes to your mind is to run a loop. Simple. So if it is like say 1, you say I will run a loop from 1 saying 1 plus 2, 1 plus 3, 1 plus 4, 1 plus 5, 1 plus 6. And then I'll start that loop from 2, 2 plus 3, 2 plus 4, 2 plus 5, 2 plus 6. Make sense? That means I am going to start from 0 until n minus 1, where n is your total elements. And your j, I'm going to start from I plus 1 to n minus 1. Because I want two different indices. Make sense? Right? So this is going to take your time complexity of O(n) square and the space complexity of big O of 1. Makes sense? Right? Another thing, what we have is approach number 2, let's say, is use a hash map. So what am I going to do in the hash map? I've been given the array as okay. What I'm going to do is I'm going to see my first element. And then I'm going to maintain a hash map. And then I'm going to see 1. Is my how much less is 1 to my target? So if let's say my target is 10, 10 minus 1, 9. 9 I'm going to push in my hash map along with the index. Then I'm going to come to 2. Is 2 present in the hash map? No. Then what I'm going to do? I'm going to push 8 and index. Is 3 present in the hash map? No. What I'm going to push? 10 minus 3, 7 and its index. 4. Is it present in the hash map? No. What I'm going to do? I'm going to push 6 along its index. 5. Is this present in the hash map? No. What I'm going to do? I'm going to push 5 inside my hash map. And then 6. Is this present in the hash map? Yes. So what I'm going to do? I'm going to return this index and this index. Basically index plus 1 actually. Makes sense? So here your space complexity becomes big O of n while your time complexity is big O of n. So we improved our time complexity from big O of n square to big O of n, right? But the space complexity has been deteriorated further from big O of 1 to big O of n. And maybe that is what we need to work on. So let's come to your approach 3. Your approach 3 is your optimal approach that makes use of two-pointer technique. I want your undivided attention right now because once you've understood what we're doing, it's just as simple as any other question. So let's say I have this array. The target I'm going to keep same, that is 10. What I am going to do here is I'm going to initiate I here and j here. But the first and foremost requirement for this is input array should be sorted. Okay? So if you've been given a non-sorted array, you have to sort it first, but then you'll be able to return the element. So let's just talk about this first, because the input array has been given sorted to us, right? In that case, I have j. What I'm going to do is I'm going to find my answer. So my answer is 1 plus 7, 8. Now, is 8 greater than target? No, 8 is lesser than target. So what will I have to do? See, if this increases from here, value increases, right? Or I would say, keeping my j constant, if my I increases, comes to this side, my answer's value increases. Make sense? If my j decreases, keeping I constant, my answer's value decreases because 7, 6. Makes sense? Okay. So your answer is 8, but you want 10. You have to add something. So we do I plus plus. I comes here. Now it's 2 plus 7, 9. Again, decreased. We need to increase it. I move my I. Again, 3 plus 7, 10. We got answer equivalent to target. Now you can return it because we want to return first such occurrence. Okay. So let's just code it up. I hope you're able to understand. If not, please make use of the comment section. Please make use of the G forms attached. Let's just start with code part now. We will keep it to sum, the function name. And what do I have? I have your given array. What am I supposed to do first? I will declare left as 0, right as array dot size minus 1. And now what will I do? See, this is the important part. While left is lesser than right, and that is your 2 pointers. While left is lesser than right. If array L plus array R is greater than target. Now, if they become greater than target, then R has to come down, right? Else if array L plus array R becomes lesser than target, L has to add up. Else. Now, what is else? Array L plus array R is equal to your target. Then what? Let's say I define here your, that is to be returned, your vector int of answer. So what do I have to do? I have to just push back L plus 1 and R plus 1. Return answer and I am good. With this, what do you think is the time complexity? Big O of n. Space complexity? Big O of 1. Makes sense because we just used two variables, and if you're using variables, they're constant. So what did we do here? Our L was here, our R was here. And depending on the target, we decided if we're going to move L or if we're going to move R. With this, if you were able to extract something from the video, just go in, like the video, subscribe to the channel. With this, I'll take your leave. Thank you. Bye-bye.